Good afternoon, everybody. Thanks for allowing me to speak today on this project. As was mentioned, I am from St. Louis, Missouri, in the United States. St. Louis is known for a couple things. The Gateway Arch, which we're known as the Gateway to the West, our baseball team, and the Mississippi River. So the project I'm going to talk about today to kind of illustrate one of the larger scale nature-based solutions that I've worked on is located on the Mississippi River, much downstream from St. Louis, but kind of hits close to home, and it's a really neat project. So I thought the best way to kind of illustrate this is talk about one of these projects. If you go to the next slide. So first, just in terms of nature-based solutions, I think we're all aware of this, and there's various definitions out there. I've got a few of them on the screen, but the big takeaways I have when I think about nature-based solutions for these projects is really we're trying to do something that mimics natural processes and offers sustainable, diverse benefits to tackle the problems we're trying to tackle. So various ways to define it, but that's in a nutshell, that's how I define this. And so the project we'll talk about here really harnesses the power of the river in order to provide solutions to a huge problem down in the southern part of the United States. Next slide, please. And you can scroll through those clicks there. Yeah. So first of all, to kind of set the stage for this. So our project is located in the southeastern part of the U.S. in the state of Louisiana, on the east side bank of the Mississippi River. It's part of a larger program that's being implemented by the Coastal Protection and Restoration Authority, known as CPRA. We'll talk about it a little bit. There's a significant problem down in coastal Louisiana with the loss of freshwater marshes due to a combination of things that we'll talk about in a little bit. But this project that we'll talk about today is part of a larger program located down in southern Louisiana, south of New Orleans, if you're familiar with Louisiana and all, south of New Orleans, near the coast. Next slide, please. So to understand the problem, I think we got to understand the Mississippi River. So this slide shows the different deltas. So the Mississippi River is the largest river in the U.S., fourth largest river in the world by length, ninth largest by discharge in the world. Over the last 7,000 years or so, the Mississippi River has switched to deltas as it outlets to the Gulf of Mexico. These rivers naturally transport sediment and nutrients out towards the mouth. Those sediments and nutrients deposit. The slope of the river flattens, and the river wants to switch course at some point, and it has done that over the last several thousand. About every 1,000 years or so, it's switched courses, and these different colors on this figure illustrate how it's switched again every 1,000 years or so over the last 7,000 years. So next slide, please. So then, partially due to, as the rivers here and the United States grew, a lot of development happened, a lot of agricultural, cities grew up around the river. The river also brings with it flooding in addition to those sediments and nutrients. So in order to address that issue, there were several debates in the U.S. about how to address that. What ended up being done was the river was levied for a majority of the Mississippi River was levied back in the late 1800s, early 1900s, after a couple very significant flood events. So that, along with contributions from sea level rise and some other things down the coast, has resulted in what used to be the river would come down and bring with it all these sediments and nutrients, deposit them in the floodplain during high water season. And then those nutrients would deposit, the sediments deposit, they build land, the nutrients would provide nourishment for vegetation that would grow, and then it would provide more organic matter to that soil and sustain these freshwater marshes along the coast. Well, what's happened as a result of that combination of things, so you've got the levying of the river, which starves the floodplains of these sediments and nutrients, you have sea level rise, then you have subsidence due to the lack of nutrients and vegetation out there. The coast is essentially sinking, and the state of Louisiana is lost. You can see the stats on on the figure there, 1,500 square miles in the past 50 years. Then you hear a number a lot of, we lose U.S. football field of land every hour in coastal Louisiana, and it's estimated this is going to continue, and they could lose another 1,000 years in the next 1,000 square miles in the next 30 years. So a significant problem in coastal Louisiana. So if you want to go to the next slide. So to combat this, the Coastal Protection Restoration Authority of Louisiana was formed as a state entity to combat this. And so they publish a master plan every 5 years. And this master plan comprises a study of the area and identification of potential projects to kind of stem the tide of land loss, hopefully sustain some of this land that is being lost due to those processes I described. So there's different types of solutions that they've identified, some non-structural, some structural, consisting of things like ridge restorations, shoreline protections, barrier islands, marsh creation, and sediment diversions. So sediment diversions are some of the cornerstones of this, and I'm going to talk. There's 2 sediment diversions that are currently programmed and in the design and construction phase, and I'm going to talk about one of those today. So if you'll go to the next slide. So we'll talk about the Mid-Breton sediment diversion. So the Mid-Breton diversion is located on the east bank, or it's the left descending bank of the Mississippi River. The Mississippi River in flood season, the discharge annually is typically around 1 million cubic feet per second. I guess 28,000 cubic meters per second. So it's significant flow. The goal here is to divert about 5% of the river into what's known as the Breton Sound or the Breton Basin in the east, kind of on the east side of the river there. And again, reintroduce those sediments and nutrients back into the Breton Sound. And with that, kind of promote vegetation growth, turn this back into a freshwater marsh, and again, stem the tide of land loss. So if you'll go to the next slide. So this is just a rendering of this. And so you can see the river on the left flowing from the top left side of your screen to the bottom right. And we'll talk about the different features in a second, but this kind of gives a big overview of what's going on here. We have the river, we have an intake on the diversion. There are levees on both the front side to reduce the risk of Mississippi River flooding and the back side to reduce the risk from coastal hurricane-induced flooding in this area. The diversion will cut through those, and so it would be a gated diversion structure with 3 large gates on it, and then a channel that will convey flow out into the Breton Basin. So if you want to go to the next slide, I'll talk about these components. So there's 4 major components, and we'll talk in a minute about I'll give a kind of highlight of how we're using nature to taking advantage of what the river offers in order to build land out here. So I'd say if you go from left to the right, there's 4 main components. So number 1 is the intake channel, where this is what collects the sediment, the water and sediment from the river, and starts to move it through the channel and out into the sound. So this ties into the riverbed. There's a point bar just upstream of our location, ties in the top of that point bar, and then conveys flow through the channel. Again, there's a gated diversion structure. It's 3 50-foot wide gates. I mean, so this is a very significant structure that those gates will remain open during high river flows. They'll be closed if they have the ability to be closed if there is a hurricane approaching from the sound side to reduce the risk of kind of a funneling effect and moving any surge elevations upstream. Then we have a conveyance channel, which is an armored channel with riprap that will move flow towards the sound. And then there's number 4 is we have an outfall feature which transitions this fast moving water and sediment into the sound in a manner that tries to balance. We want to have enough energy to move these sediments and water out into the sound, but do it in a way where we don't cause scour erosion significantly out into the marsh. There will be obviously some erosion. We want that because that's going to create these distributary networks that convey these sediments out into the sound and therefore build land. But we want to do that in a way where we can manage it, have it be manageable from a design standpoint. So if you'll go to the next slide. So one thing we want to do here is, I said, like, in terms of using a nature-based solution, we want to harness the power of the river. This is mostly a passive structure. Once this is built, it'll mostly operate in a passive manner. So there will be a head differential between the river and the sound that will allow it to push the flow through there. We've done a significant amount of surveys and hydraulic modeling and sediment transport modeling to evaluate this. And this slide just illustrates, you can kind of see on the river slide there, there's a point bar just upstream of the mouth of the intake of our diversion. And as flow moves around this outside bin, it kind of creates these secondary currents that actually move flow towards the intake. So we're kind of harnessing that natural process of the river in order to allow the diversion to form more effectively. So this involved a lot of study to site this in this location to take advantage of those natural processes and move flow towards the river. The figures on the right just show the submitted sediment concentrations. Higher concentrations are in red. So we've got these higher concentrations over there near the intake, again, due to this the presence of the point bar, and we want to take advantage of these sands and silt type materials that move across the top of the point bar, because those are what's going to form the foundation of land building out in the sound, and that'll eventually happen. If we go to the next slide, just to kind of button it all up. So this is we've got some preliminary model estimates of delta evolution. So as we take this flow in from the river, it's going to move out into the sound. And again, like I mentioned before, we want it to have enough energy that it can actually carry these sand and silt type materials out into the sound, because these sands are going to fall out first and form sort of these natural levees that then will trap some of the smaller, finer grain sediment particles and eventually breach and form new distributary channels, which will then kind of do the same thing in a crevasse splay type process. That's what's going to lead to land building. There's a significant amount of modeling that's been done to estimate this, but this just illustrates sort of the approximations of the significant amount of sediments that can be deposited and positive change this project can cause for moving these sediments in vegetation or the nutrients through the diversion and into the sound. So we've got, we're estimating up to a couple feet of deposition out here in several areas for a large area out in the sound. So with that, appreciate the time today for allowing me to talk about it. It's a really great project. You can go to Coastal Protection and Restoration Authority's website and learn more if you would like. So thanks, Alistair. Turn it back to you.
Thanks very much, Matt. That's fascinating and an incredible scale that you're doing this at. Okay, we're going to move on quickly to our next speaker, who's Matt Wheeldon. And Matt's from Wessex Water. He is a chartered civil engineer with nearly 30 years of experience working in the water and sewerage sector in England and abroad. He's worked for Wessex Water for 24 years now and was the water industry representative on DEFRA's Storm Overflow Task Force. Matt is going to talk to us about why society and the planet needs more localised rainwater management. So over to you, Matt.
Thanks, Alistair. Unlike the previous Matt's presentation, I'm not talking about a massive project. I'm talking about how I think our attitude and our approach to rainwater needs to change as a society. Can I have the first slide, please? Thanks. I think it's fairly obvious that our weather patterns are changing as a result of climate change. We have noticed it. And I feel that in England that our weather is very much going from that horrible, boring drizzle to slightly more exciting and scary periods of drought followed by thunderstorm. Next slide, please. You've probably read all the media. Last month was shocking when you looked at global temperatures. And we're obviously experiencing some of that in our high latitudes here in England and the rest of the UK as well. So what scientists are seeing on a global scale is being somewhat reflected, though maybe not as extreme as other parts of the world, but we are experiencing here in the UK. Next slide, please. we're noticing a general increase in mean temperatures. That means that if that mean moves slightly, we're going to see large increases in the number of above average events. We're also seeing increases in variability of weather, so more extremes, and that too is leading to more hotter weather and indeed more colder weather. When you combine the two together, what you see is, next slide, sorry, next part of the slide. When you increase the mean temperature and greater variance, you see a greater probability of extreme hot weather, but not necessarily of more cold weather. And we are very much experiencing that. And as we've looked at all the records over the past couple of decades, the data that we're picking up, the measurements, are certainly reflecting that idea, that concept that has been predicted. Next slide, please. So not only are we seeing hotter weather, but as the atmosphere warms up, we're seeing greater and more extreme rainfall events. Every 1 degree that the atmosphere warms up, it can hold about 7% more moisture. And so the events that we're experiencing, it seems to be more frequent now, are more tropical-like, the kind of downpours that we get in the tropics. And that is just because there is just more energy to hold more moisture, and then when it comes down in a much harder fashion. Next slide, please. I just wanted to show something that happened earlier this year in Somerset. This is at North Cadbury, where over that small village we had a rainfall event in May that had a very low probability return period, 1 in 1,600 years, which in itself is quite incredible. But I wanted to draw you to the fact that just a few miles away, there was very little rain, extreme rain at all. So we're seeing very much localized thunderstorms, and it makes dealing with it far more problematic when we don't actually know where this is going to happen next. Next slide, please. Never before has better rainwater management been so important for ensuring we have enough water when there is scarcity and we are protected when there is excess. That's my view, and I want to explain why I think that is so true. Next slide, please. We're not good at managing rain. We work in our society, which is quite a highly evolved society, on a centralized approach to rainwater management. In other words, we rely on water companies to provide the rain in a treated format so that we can use it in our homes. So that rain that's landed in river catchments or into aquifers, we treat and we supply. And then in our homes, we use that highly treated water, which is all to drinking water standard. Next tab, please, Lewis. Which is all treated as top level quality for drinking. We then use for numerous other purposes as well. Purposes that don't really need that level of treatment. And then on the wastewater side, again, we rely on a centralized model. Let's get rid of the rain that's landed on our roof and send it off to someone else. And because we've got a one pipe serving the majority of properties in our country, more than half of the countries in England have a single pipe, a combined drain draining them. And the volume of rain that's going down those is so much greater than the volume of water coming out of the showers and toilets and sinks. We have this problem that we all know about called storm overflows. So we have a one pipe problem on the supply side, where we are over-treating most of the water we use, and we have a one pipe problem on the drainage side, where we're trying to combine small volumes of sewage with very large volumes of rain. Next slide, please. I think there are two golden principles of good rainwater management. In my thinking, I always come back to these two. So the first one is this, and by the way, these are not rocket science. I'm sure I'm teaching to a converted audience already. Rainwater should be first and foremost treated as a resource captured near where it lands and reused where possible. Common sense. Principle 2, drainage. Rainwater should be returned to the environment as close to where it landed as possible and never mix with sewage. Well, Matt, you're saying that's obvious, isn't it? It is obvious, but we're really bad at it. Next slide, please. So at the moment, I talked about we have a centralized system. We rely on a water company to provide all our water, and we rely on a water company to take away all our rainwater. And we sit in the middle as society. So here's a top level view of that whole water cycle. And I want you to take an interest in the thickness of the arrows, because I'm trying to illustrate quantities here. So our home is fed from a treatment works which has collected the water from previous rain. Next tab, please. And then we add our roof water to our contaminated water we've used in toilets and washing up and stuff. And we send it down a collecting system that can't carry it all. And that's why we have overflows, which is the top green line. And then the majority of it still goes on to treatment and gets returned to the water environment. That's a centralized approach where we're relying on upstream and downstream providers for all of the services. In a more decentralized approach, we are consuming less of the water in the home because we are harnessing that first principle that rainwater should be first and foremost considered as a resource, captured locally and reused where possible. So our demand of the treatment and distribution system will invariably be lower because we'll be doing some self-supply ourselves. And the next bit. It also means we'll be returning less rainwater back into the sewage collecting system, which will invariably help with the whole storm overflow problem that we have as a society. So what I'm basically saying is that a localized or decentralized view or approach to rainwater management has multiple benefits. Let's just go to the next slide. What does this look like in practice? Next bit, please, Lewis. It means a range of things. It means from the simple water butt to more complicated rainwater harvesting systems. The latter being very difficult to retrofit, but we don't even get it right with new development. Sustainable drainage means getting it back to your garden where possible, back to ground, back to watercourse, or where you can't meet those two, the SUDS hierarchy, surface water sewer, highway drain. And only in extreme cases, returning it to the combined sewer. Next tab. And that's where I think the opportunity for upstream offsetting needs to be considered, whereby if someone has no choice for various reasons, that they have to ensure that the equivalent rainwater that they are adding to a combined sewer system is removed upstream. Okay, next slide. So if we move to a more localized rainwater management approach, there'll be various consequences to that. If we are more localized, then from a capital cost point of view, we won't need to build so many centralized assets. In other words, taken to an extreme case, you wouldn't need to build a new reservoir up in the hills because everyone was demanding less water in those peak periods. So less infrastructure required. The downside being that in the home, you'd need more assets to manage that rain. Operationally, you're shifting a lot less of this very heavy substance called water around, and therefore operational costs are going to be lower because the water company is going to be taking more out of the environment, treating and distributing less, and therefore there's less flow to collect, pump and treat. And then on the customer side, more local assets, you're going to have fewer costs because you're demanding more or less of this centralized service and supplying less to the centralized service. From a carbon footprint point of view, less infrastructure means less carbon in the centralized part of our whole model, but a bit more at the localized level, and operationally significantly lower operational carbon costs at the extremes, and probably a little bit of a positive increase for our local domestic assets to reuse that rain. Biodiversity and well-being, more difficult to measure, but certainly if less construction up at the top end of the water cycle, and hopefully more engagement in the water and in people's gardens will lead to a positive approach to biodiversity in the home. And yeah, difficult to measure well-being. So how good are we in England? Well, new development currently does not have to be water efficient, which is shocking in today's day and age, bearing in mind that well over half of the country is water stressed. New development does not yet have to be sustainably drained. We're hoping that's going to change next year when Schedule 3 of the Floods and Water Management Act gets enacted. It'll only be 14 years late, but it's still not there. And we're still allowing people by law to connect rain to sewers that carry foul water and continue to exacerbate the whole storm overflow problem. So I've given us a D-, room for lots of improvement, but we've got to change these things and get it right for new development, which is probably easier to do than retrofitting it for existing development. Okay, my final point I'd like to summarize is this. As a water company, which I represent, we really want your poo, but please keep your rain. Thank you very much.
Thanks very much, Matt. So maybe you didn't hear it first, but you definitely heard it loud and clear from Matt. The future's decentralized and we can't get there quick enough. So we're going to move on to our final speaker now. That's Adrien Beaudumont from Syria. Adrien is a research manager at Syria. He's working on sustainable water management and biodiversity. He has a background in environmental planning, water resources management, and nature-based solutions. He gained recognition for his management of innovative water quality improvement projects in the San Francisco Bay Area before crossing the pond to advance a suite of research projects involving surface water, biodiversity, nutrient neutrality, and much more within Syria. Adrien's going to talk to us about empowering communities to improve local climate resilience and give us a feel for the upcoming Syria guidance on enabling community maintenance and local flood risk management. So, Adrien, over to you.
Thank you, Alistair. Next slide, please. All right, so just a quick introduction on Syria. I'm sure you're all aware of what Syria is. This is the Construction Industry Research and Information Association. We are a not-for-profit member-based organization, and we aim to improve performance in the construction industry. And we do that by delivering a series of outputs, including guidance, training, and networking events. And I will talk a little bit more about that in the next couple of slides. Next one, please. All right, this is our members. As of today, you can see there's a whole range covering the full spectrum of the construction industry in the UK. We are very proud of this, and this is thanks to all of you members that we can advance research project like the one that I'm going to be presenting on. Next one, please. The 5 types of outputs here that you can see on the screen, so I'm going to run through them very quickly. The most famous ones are our guidance documents, and here you can see the SUDS manual on screen and a couple more that are popping up. We cover a whole range of topics, but with a focus on civil engineering and also soil and, of course, surface water management. We offer trainings. The most famous ones are the around SUDS. So we have SUDS foundation, SUDS inspections, design, etc., etc. But we also go beyond SUDS for training. Next one, please. And then we have our networking event. 2 more clicks, please. You will see we have annual lecture, debates, and we run a series of awards. We had the SUDS Awards in the summer, and we are having our Biodiversity Awards in a couple of weeks, on the 15th of November. COPS stands for Communities of Practice. We have several very successful focus groups on very specific topics. The first one, the most successful one, is SUSDRAIN, everything SUDS related. Then a couple more clicks, please. Thank you. We have Build of Sites, Syria Soil, and Syria Biodiversity. Lastly, we are also providing tools, and 1 click, please. So this is the most recent one is Syria Best, which has been around for quite some time, but we are relaunching it as an online application. And this is to quantify the benefits of blue-green infrastructure. Next one, please. All right, now back to the project, the research project, which is on guidance on enabling community maintenance for local flood risk management. The background and vision is really about opportunities and opportunities for communities. We heard these past years some feedback from our members and partners that we work with that there was a will for local organizations and local groups that have flood risk management assets around where they live to be able to do some maintenance of it, simple routine maintenance in some cases. And so when we heard that, we decided to start this research project, and we want to really understand what are the risks and responsibilities around maintenance of flood risk management for local communities, and also what are the assets and maintenance requirements, and how to effectively engage. Next one, please. How do we understand community maintenance, or rather, how do we define it within this research document? Well, we define it as activities by flood action groups or other voluntary groups affiliated to communities like parish, town, or villages, designed to inspect, maintain, sustain the performance of flood structures, channels, and basins. So this is basically what we're working, the definitions we're working with. The key driver for this document is really about empowerment and not delegation. This is a document that is for a voluntary approach of management and maintenance of flood risk management structures. This is really for the flood action groups and communities that want to do it. And if they want to do it, we want to make sure that they have some proper guidance to do it safely. All right, next one, please. So this project is ongoing, which means that the guidance hasn't been completed yet. It is a two-phase approach. We just completed phase 1, and we are starting phase 2 now. I'm going to run through the outputs from the phase 1 and then talk a little bit about what to expect for phase 2. The outputs of phase 1, which I will go into more details about, are really, the first one is a brief for policy and strategy staff. This is basically the why. Why do we want to do it? What is the existing context in terms of involving communities into the maintenance of flood risk management structures? What is the existing policy context, etc. The second one is really the high-level principles document, which will be guiding the writing of the actual guidance document. And which leads me to phase 2, which really are 2 separate guidance documents, one for risk management authorities with approaches on facilitating and enabling community groups to undertake maintenance. And the second one is a proper guidance written for community groups, which is really the how to do it and where to start if you were a local group and you want to do some maintenance of the flood risk management features around you. Next one, please. For each and every project at Syria, we fundraise through the industry, and then we tender to get the most competent and the most knowledgeable entity to actually lead on writing the guidance. And so for this project, we have a team led by HR Wallingford, but we also have on board UNOMIA, the Flood Hazard Research Center, Adaptation University, and the Flood Forum. We have a process for each of those research projects, which is an iterative process, which means that the research contractor will work towards drafts for those guidance documents, which will be reviewed all along the way by a steering group. And here you can see all the different entities that are part of this. We are really thrilled by the wide reach of the steering group. We're very hopeful for a successful project. Next one, please. Can you hear me? Okay, perfect. All right, progress so far. As I mentioned, this project is not complete, but we started with some engagement work. We had a survey that showed that many of these local groups were already carrying maintenance activities, and they've been doing so for quite a long time. So the idea was to get a little bit more details about what type of activities and who's involved. And we did this through a series of interviews. Next one, please. We had a workshop early in the year to gather feedback from local community groups. It was very successful. We had 30 plus community groups members joining and giving us their feedback on the outputs that I'm going to be talking about. I hope you guys can hear me okay. I'm having some signals here that my internet connection is quite low, but hopefully it's okay. Right, so the first output is this brief for policy and strategy staff. The aim was really to show how community maintenance could be part of flood risk management, and wanted to enabling and supporting, but not delegating any of these responsibilities. So we define these as activities led and owned by communities, working with and guided by relevant authorities when needed. Next one, please. The boundaries of this research document are inland work. We could not include coastal in there. That would have been a whole different beast. So this is really about inland and freshwater management. The key point for this whole document is safety. So we highlighted activities that we will not promote and that we will actually highlight as something that could not be done by community groups. It's fairly logical, but you can see here on screen, subsurface and confined space flood management structure are a no-go. Activities when flood management structure are operating as well. The ones requiring especially trainings or equipment, etc. So we really want to make sure that whatever happens is something that happens safely. Next one, please. A couple drivers. I think we've heard those through the different presentation before. Flood events are very localized, and so the local aspect of it means that it's really important to have local eyes on the ground and to promote active involvement and multi-stakeholder governance. And of course, practical drivers. We know that the resources are limited on the risk management authorities side, and we heard from the communities that there is definitely a need for it. And of course, we're facing increased flooding in the future. And also the increased implementation of SEDS with hopefully the implementation of Gather 3 next year. Next one, please. All right, a couple of opportunities and also liabilities. I'll go very quickly, but basically we want to make sure that the roles and responsibilities are clarified in this document so people know what to do and what they have and what they should not be doing. And of course, insurance is a big topic. So we're thrilled to have Floodray on board to help us with that. I want to make sure that the work that is being carried out is properly covered. Next one, please. Okay, now the second output of this phase one is really the high-level principles for community maintenance. I'm going to rush through those because time is ticking, but what I want to highlight is that these are high-level headers that will guide the writing of the actual documents. And on my second to last slide, I will give you a little bit of a preview of one of these, of the contents of one of these actual guidance documents. Next one, please. The first principle is to be clear and realistic about local flood management situations, which is really knowing what you can do, what you cannot do, who to contact, and where to find the resources to do so. Next one, please. Second one is really working together and communicating with others. It seems like, something very logical, but it's actually very important to know where to search for skills and resources, and also to recognize the roles and responsibilities of the different entities and actors surrounding a local context. Next one, please. Number 3 is about caring for the local environment. Of course, this is a leading principle. Next one. Number 4 is about safety. Once again, health and safety is really critical and center into this project. Next one, please. Sustaining and evolving the community maintenance group, how to maintain it in the long run, how to maintain contact, and how to transfer the contact and who does what when there's transition within the community maintenance group. Next one, please. Oop. All right, and ensuring activities are relevant and actionable. All right, next slide, please. Okay, so I've talked about where we are today, which really is the end of phase 1 and the 2 outputs that I just presented on. One for strategic and policy staff, and the other one really high-level guiding principles that will lead the development of the guidance. The next phase now will be to write those guidance. So one for risk management authority and one for local community groups. And we are aiming for a publishing around the second quarter of 2020. Next one, please. Next slide. Yeah, thank you. This is my last slide, I believe. Whoops. Yeah, thank you. I just want to give you a little preview of the contents of one of those documents, which will be the one aimed at community groups. So you can see what we are going to be developing in this document. So you can see we're going to be talking about the context of community maintenance. We're going to talk about the flood risk, the stakeholders, and the assets. We will go over roles and responsibilities, skills and resources, but also how to set up, structure, and fund such a group. And of course, we will dive into the different types of maintenance activities that can be performed within such a group, working with wildlife, health and safety, etc. And if we zoom in a little bit on the specific activity guidance, you can see a couple of those that are listed. This is not an exhaustive list, but you can see here tree, weed, and debris clearance, sediment management, vegetation management, invasive species, inspecting and clearing inlets and outlets, pipe and culverts, litter picking, etc. All those within the purview of the safety protocols that we talked a little bit earlier. And next one, I think that was my last one. So I want to thank you for the opportunity to talk about this project, and I'm happy to take any questions once we open it for the group discussion. Thank you.
Thank you ever so much, Adrian. That was great. Can I ask all of our panelists to pop your cameras back on? And we've got about 10 minutes left, so we'll do a little bit of Q&A. There's a few questions have come through the Q&A, and I've got one or two myself I might pose. So let's see how we crack on. Just going in order of the speakers, really. Matt Hoy, got a couple of questions for you. The first one through the chat, actually, from Georgia Kamana, who's asking whether the flow diversion impacts sedimentation further downstream or not.
Yeah, that's a great question, and one that CPRA studied for a while. So as you might know, the Corps of Engineers who manages navigation on the river, they're almost continuously dredging the lower part of the Mississippi River for navigation purposes to maintain that channel. So this has been and there's several anchorages along the kind of, I'll call them near field areas of the river to our diversion. So one of the big concerns with these sediment diversions is that, you're losing stream power as you pull off some of this flow. You reduce the amount of flow in the river, you lose stream power, you lose the ability to transport sediments downstream. So that's been a big concern. One of the ways that it's been addressed, I guess, or evaluated and addressed through the projects is to look at the sediment water ratio of materials moving through the diversion. So we want to kind of proportionally capture more sediment than we do water, you know, in the through the diversion. So we've looked at that, and that's where, in this situation, being located adjacent to this point bar where we have high concentrations on this inside of the bin here as it comes over the point bar, and we're able to harvest that. We can actually harvest kind of proportionally more sediment than water, so we actually can reduce the chances of deposition, increasing deposition further downstream. We studied immediately adjacent to the structure using models to look kind of some different approaches, some Delft models, some sort of just conceptual mass balance models to look at potential deposition in some specific areas. There's some very isolated areas where it could result in some deposition, but those are not as significant as what we kind of once wondered if they were. So that's good. And then large scale, it doesn't look like it'll have an overall significant impact one way or the other on deposition further downstream. But that's a great question, because that's been asked a lot throughout the evolution of these projects.
Right, thanks, Matt. Yeah, that's great. There's been a couple of questions asking if I don't know if there is a scheme website, but if you'd be able to share the link in the chat.
Yes, I will.
For that'd be fantastic.
Yep.
Going to move on to the other Matt now, and a comment from an anonymous attendee about the ability to retrofit stuff. So you talked quite a lot about putting these rainwater harvesting measures in and improved drainage measures into new development, and the fact that really hasn't been happening when it should have been. Are there other suggestions beyond water butts for gardens that can practically be done for many of the millions of existing properties like you get in London and big cities? What are the options there? And there's someone else also asking about water company incentives to do that kind of retrofit as well. So I don't know if you want to answer those in tandem, Matt.
Yeah, in built-up areas with small gardens, there's far less flexibility. Basically, as a society, we haven't made space for water, and that's the problem. We have a centralised approach to rainwater management. So the opportunities will be limited by the soil types and the space available, but we don't generally make most of it. So the water butt is really more about the water efficiency side. It's the overflow to the water butt that is the drainage side. And one of the problems is, of course, we don't value the service, because, I mean, in the Wessex area, you pay £25 a year for your whole of your roof to be drained all year. So, and that's not a huge amount of saving. And so the cost of retrofitting always exceeds the sort of saving you'll have. So it doesn't stack up at the moment economically. So we certainly try to incentivize new developers to not connect rain. We charge them 10 times the amount for each property for the infrastructure charge for where they keep the rainwater away from the foul sewage as a disincentive to doing the wrong thing. But yeah, there are some. What I'm not saying is that this can be done everywhere. What I'm saying is where there are opportunities, we should be grasping them. The financial incentives for. I'm in exactly the same situation, in that my house, the rain goes into my drain where my toilet goes, and I've been looking at the cost of putting in soakaway, a rain garden soakaway in my garden, and it's several £1,000s. It doesn't stack up. What I would like to see is water companies incentivized to do this for customers. At the moment, water companies are only incentivized to reduce discharge numbers from storm overflows, and then to try and reduce consumption in the tap. If you bring these two things together and say the solution can be dealt with in the home, then rather than building big storage tanks for combined sewage, we would help with more separation at source. One of, I think, the problems is the attitude is that this is all seen as a water company problem rather than a societal problem because it's a centralized management system. And whereas you can get a grant to insulate your loft or to put solar panels in, you can't get a grant to harvest your rain. Why is that? Because government doesn't recognize it as a societal problem. It thinks it's a water company problem because storm overflows are water company assets and water efficiency are water company targets. So it's a really interesting philosophical and political debate as to where is the responsibility. Water companies will build bigger dams and they'll build big storage tanks for combined sewage. Not the best solution when we looked at the pros and cons. So how do we change that whole approach to actually the best place to tackle this quite often is in the home, and how do we then leverage that knowledge and that ability and the finances to do it? Is it through a tax or is it through your water and sewage bill? At the moment, water companies don't have, because we're measured on these other things, we're not measured on the area separated or the volume captured for reuse. We're measured on the number of storm discharges. It's driving companies down that sort of suboptimal route of not better rainwater management, but better combined sewage management, which is quite short-sighted in my opinion.
So there's potentially a range of different regulatory approaches that should be brought in effectively, Matt.
Very much so, but it needs the politicians to understand the broader context, and that localized rainwater management is the better longer term solution rather than just saying, right, water companies, stop that storm overflow discharging. We don't care how you do it. They should care how we do it, because unless they encourage us to help us to work on assets that are not ours, because we don't have powers to do that, obviously, that don't belong to us. But we see the wider benefits of that better rainwater management. We're going to carry on building bigger dams and bigger storage tanks. And that localized rainwater management will not happen en masse. It needs the finances and the incentives to make it happen en masse.
Yeah, agreed. Looking at time, I'm going to give Adrian the chance to answer one question. So we'll do one each. And there's a question about, I think, really pointing at scale for this kind of community engagement with maintaining flood assets, and a suggestion from William Hamilton that maybe you might need some kind of overall membership organisation to help kind of mobilise community volunteers. And he suggested the National Trust. Have you looked at that, or are there kind of, I mean, flood action groups you mentioned, are they a good vehicle for mobilising people around maintenance?
Yeah, so we work closely with the National Flood Forum, which are really our conduit to reach to local flood groups. And I think it's been working quite well so far. And we're hoping that once we have those documentation and guidance documents ready, we can use not only their channels to disseminate those, but also, honestly, any other channel that can reach to the local communities. We will be thrilled to add it on. The idea is really to create something that is useful for as many groups as possible, and hopefully reaching through the National Flood Forum and others will be very useful. We also have, the EA is part of the project. There's a lot of stakeholders that will be disseminating and talking about those documents when they're ready to go. But thank you for the suggestion.
Sure. Right. Brilliant. Thank you. Okay. I think we need to bring things to a close. So if I can just take the opportunity to thank everybody involved, and particularly our speakers today, Matt Wheeldon, Matt Hoy, and Adrian Beaudremont. Great presentations. Thanks also to the Central Southern branch for pulling this series together. Hope you've really enjoyed it. I think it's been fascinating today. If you haven't been able to catch them all, you can catch them on YouTube, as I said. So thanks ever so much, and we'll bring it to a close.